Hey, we'll continue our discussion on dynamic programming with longest common subsequence. Given two strings, text1 and text2, return the length of their longest common subsequence. If there is no common subsequence, return 0. So remember, when we talked about dynamic programming, we would have some DP array, at which the elements would represent the states, and we have to find some transition between the states. We see that we're actually comparing two things here. So some very common way to tackle these types of problems, especially when we're comparing two things, is to use the two-dimensional 2D dynamic programming. So instead of an array, we'd have a matrix of states. You may not be too familiar with it and how it works now, but you will get better with practice. 2D DP problems are a little more complex into how someone can come up with their states. It may have already been a little complex in the previous video on how to think about common states for them, but let's try to reason through it. So the state that we're going to use is for dpij is going to represent the longest common subsequence. We'll abbreviate it as LCS of, let's say, text1 and text2. So going to be T1, the longest common sequence of T1 going up to I, and T2 going up to J. This may seem a little weird and kind of arbitrary on how we came up with this state representation, but it may become more clear when you go into the transitions between the states, because usually the transitions between the states are a lot easier to calculate given this storage. Now, you may have already thought of a way to transition between the two states given this. Let's consider some cases. So when you're thinking about the case where a number or we're on a letter, for example, let's say it's going to be 4. So the first 4 versus, let's say, the first 2 here. So dp, let's say if this is the first word, this will be dp 2, 4. And if we're evaluating, or actually let's say 4, 2 here. Let's put this first because it's a larger string. If we have this d here, if we're evaluating this d, we see that it actually doesn't get used in the final max substring. You could look in the example. So when it's not being used in the substring, well, the answer to the DP is going to lie in either the smaller substring of ABCD, because again, D does not factor in it, so it lie in the smaller substring. Or it could lie in the other smaller substring. Again, it depends on which one we're at. Okay, so to more formalize it, we have two cases for not in final. So the two cases are dp I minus 1, j, or dp I j minus 1. This would end up being in the same one of these two. Well, what if we're just 1, 4? Like I said before, this and this, it depends on the ABC. But let's say we start at ABC. It can't really depend on AB or just A, since C is going to get used. So in this case, how do we know if C is going to be used? Well, again, it's more of a test and set, right? Because we're still looking at the previous strings, but we also take into consideration adding this to the subsequence. And we can choose to add it to the subsequence if they are equal. So in this case, C here and C here match, they're equal, and so we can consider adding that to the final substring. And when we do add it to the final substring, it would just be the previous plus 1, since we decided to add that. Here's our final case. Plus 1. So everything except for the final character plus the final character. And so now we have these 3 cases. Let's go ahead and put them into code. To simplify things, I'll use N and M for the lengths of text 1 and text 2. Let's create our DP array. I would actually want to create this using n plus 1 and m plus 1 of size n plus 1. And you'll see that later is because it would be easier to avoid some edge cases, especially because, as you notice here, I minus 1 and j minus 1, right? But I minus 1 and j minus 1, if in the case of 0, then we have to do an extra edge case check. But in our case, if we make it n plus 1 and n plus 1, and we start at 1, well, 0 is already done for us. So we don't have to write an extra if statement. However, there is some more things there is one slight thing that we have to remember. So for example, when we are doing the comparison, remember this case only applies if AI is equal to BJ. All right, call it A, where A and B are the text 1 and text 2. That's the only case that would happen. And so if you think about this statement, if we shift everything by 1, we have to subtract 1 to do this operation or this comparison. So let's put this in code, I in range, and we start from 1 to n plus 1. We start j from 1 to m plus 1. And then let's start with the first 2 cases. Ij would be the max of dp I minus 1, j I j minus 1. And then we do the check. So text 1. But remember, we have to subtract 1 because we've added 1 earlier. Then we do, we can check to see if there is a max. So we check to see if it's just the old value that we calculated. If just this would represent this value that we calculated earlier, or it could be the new one that we gained. So I minus 1, j minus 1. And now, if we think about it in terms of this sub question, the overall question basically asks for I equals the length of text 1 and j equals the length of text 2. In other words, it asks for the last element or the bottom right element in this case because of the matrix of. So we'll just return that. Okay, so let's submit this and see how we do. there we go. Thanks for watching, and I'll see you in the next one.